Okay, this is our functions unit, packet number 2, function notations. Okay, functions are fundamental tools that convert inputs, values of the independent variable, our x value, to outputs, values of the dependent variable, which is our y value. There's a special notation that is commonly used to show this conversion process. The first exercise will illustrate this notation in the context of formulas. Evaluate each of the following given the function definitions and input values. So f at x is equal to 5x minus 2. They want us to evaluate and find f of 3. So wherever there's an x value, we are going to substitute the value of 3. So it's going to be 5 times 3 minus 2, that's 15 minus 2, equal 13. F of negative 2, 5 times negative 2 minus 2, that's negative 10 minus 2, negative 12. G of x is equal to x squared plus 4. What is g of 3? So I typically put the x value I'm substituting in parentheses. So that's the parentheses of 3 squared plus 4, which is going to give us 9 plus 4, which is 13. G of 0 is 0 squared plus 4, which is equal to 4. H at x, or h of x, is equal to 2 to the x. What is h at 3? We learned in the first lesson we can use our store key to evaluate. So we're going to input 3 store x, then we're going to press enter, and then we're going to enter 2 to the x, and our calculus screen is going to read 8. So again, we can use store. So we store negative 2. This is when store becomes particularly advantageous. You don't have to worry about that you may make a sign error. Negative 2, store x. Again, remember you can press second enter twice, and then your calculator is going to read 0.25. You can leave it as a decimal, or press the math key, number 1 for fraction, and press enter, and it will convert it to 1/4. Alright, if you see this notation could be confused with multiplication, the context will make it clear that it is not. The idea of function notation is summarized below. Your output value is your y value, and the x value in your rule is your input value. Recall that function rules commonly come in one of 3 forms: equations, as in exercise 1, graphs, and tables. The next few exercises will illustrate function notation with these 3 forms. In exercise 2, boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are now given in the table below. In this scenario, the temperature T is a function of the number of hours H. Evaluate T at 2 and T at 6. So we're going to look at our table, in which H is equal to 2. What is my value for T? We look at our table, and when H is equal to 2, T is equal to 104 degrees. Now T at 6, when H is equal to 6, we can see t is equal to 68. Now for B, for what value of h is t at h equal to 76? So t at h, we want an output equal to 76. So the bottom row is our output. So let's look at our output, find where t at h is equal to 76. You can see it right there. And what is our value for h? H is equal to 4. Between what two consecutive hours will t at h equal 100? So let's locate where 100 will be on our table. So t at h equal to 100 will be somewhere between 85 and 104. So between which two values of h will that be? Between 2 and 3 hours. Exercise 3. The function y is equal to f at x is defined on the graph below. Answer the following questions based on this graph. So you can see we're just given a graph. We're told that it's a function. We can see it is a function because it does pass the vertical line test. We do not need an equation for our function. We just want to know what is f at -1. So in other words, if we have an input value of x is equal to -1, what will our y value be? So let's go to our graph and plot the point where x is equal to -1. So where x is equal to -1, that's our point. What is my value for y there? We can see my y value will be 0. So y will be 0. So f of -1 will equal 0. Now f at 1, again, let's go back to our graph and see where x is equal to 1. What is the y value on our function's graph? So when you have x is equal to 1, that is our value for y, and it looks like it is y is equal to 4. So f of 1 is equal to 4. F of 5. So again, let's look at our graph and find where x is equal to 5. So we have 1, 2, 3, 4, 5. And the value for y there is going to be here, which is -4. Evaluate f of 0. So when x equal to 0, what is our y value going to be? So let's plot the point where our function has a value of x equals 0. So where x equals 0 would be here. So that's the point, and it looks like my y value is 3. So when x equals 0, y is equal to 3. And what special feature on a graph does f of 0 always correspond to? Again, we learned this in the last lesson. That is where it intersects the y-axis, and we call that the y-intercept. What values of x solve the equation f at x is equal to 0? Let's recall that y is our f at x. So let's find on our graph where y equals 0. So we're going to draw a horizontal line, y equals 0. Alright, so where does y equal 0? Y equals 0 at this value here. So if you draw a horizontal line, again, use a straight edge. I know it'd be a little bit difficult to do it using a pencil, which is why I always recommend to have like some colored pencils in class. So that is the equation y equal 0. What values of x correspond? Again, let's look for our points of intersection of our graph and y equals 0. We have that point there, and that corresponds to the value x equals -1. That point there corresponds to x equals 3. And that point there to, if that's 3, 4, 5, 6, that would be 7. Let me just bring that -1 a little closer so you can see. So our values of x that solve the equation f at x is equal to 0, or x is equal to -1, 3, and 7. And the special feature is where it crosses the x-axis, and we call those our x-intercepts. Our x-intercepts always have a y value of 0. Between what two consecutive integers does the largest solution to f at x is equal to 3 lie? Again, we need to graph the equation y equals 3. So a horizontal line at y equals 3. Using a straight edge, let's graph that line. Alright, so I found 3 on my y-axis. And that's y is equal to 3. And let's find our points of intersection. There is 1, there's 2, and there's 3. They want the largest solution, so it will be that one there. And if you look carefully, it lies between the values x equals 7 and x equals 8. So between which two consecutive integers? Between x equals 7 and 8. For a function y is equal to g at x, what is known as g at -2? It is known that g at -2 is equal to 7, which of the following points must lie on the graph of g at x. Remember, that is your input value. So that is what? Your x value, -2. That is your output value. That means y is equal to 7. When you write a coordinate, recall it's x, then y. So the point is -2, 7, which is choice 2. Physics students drop a ball from the top of a 50-foot high building and model its height as a function of time with the equation h at t is equal to 50 minus 16t squared. Using tables on your calculator, determine the nearest tenth of a second when the ball hits the ground. Provide tabular outputs to support your answer. So we're going to go to our calculator, and in y1, we're going to place 50 minus 16x squared, and we're going to go to our table set, remember, which is what? Second window. Let's write that down one more time. You should start getting used to this now, though. And we're going to start at 0. Let's make our delta 1. All right, now let's press second graph, and our table shows up. And you see that y starts at 50 feet, goes down to 34 feet, then we go down to negative 14. So a delta of 1 doesn't let us zoom in on when it actually starts hitting the ground. When does it hit the ground? It hits the ground when the height is 0. So that was when y is equal to 0. So since we want to determine it to the nearest tenth of a second, let's go to our table set, and still starting at 0, let's make our delta table 0.1. So again, for second window, keep your starting at 0, but let's make our delta 0.1, and I'll press second graph and scroll down on your x value till the y reaches 0. You can see from your table that at 1.7 seconds it was 3.76 feet above the ground, and at 1.8 it was already below the ground. So when did the ball hit the ground? Between 1.7 and 1.8 seconds. So between x is equal to 1.7 and 1.8, it hits the ground. So to come up with a more accurate response, let's go to y2 and put in 0. And then what I'm going to do is we're going to press our cursor, that little arrow, and go to the left. Go to the left, and then press enter once, and what you're going to see is that a line becomes darkened. Okay? And then we're going to press second, trace, and then we're going to enter number 5 again, because we're looking for our point of intersection. And if you look at your graph, it looks something like this. We want to come up with the coordinates of that point. Your calculator states, or it says, first curve, so you're just going to press enter. It says second curve, you press enter again. Then it says guess, and you press enter again. And to nearest tenth, your answer is going to be x is equal to 1.8. Okay, so for each function, write the expression for f at x using store. Find f at 8. So we're going to press 8, store x, We're going to enter x plus 1, and then you're going to read the answer is going to be 3, because 8 plus 1 is 9. The square root of 9 is 3. And just so you know, to input the square root symbol, it's second x squared. Again, we have 8 stored. There's only to store it a second time. Go to Math, numeral number 1. And that's absolute value. Or you can press alpha y equals alpha window, and you pick choice 1. The absolute value symbols will show up, and then you're going to input the absolute value of 3x minus 7, and your answer is going to be 17. Alright, using the graph of f at x, find f of 2. So, where x is equal to 2, what is our y value? So when x is equal to 2, y is equal to 2. When x is equal to negative 5, our y values is negative 3. I'm outside, so I apologize for the background noise. F of 0, when x is equal to 0, y is equal to 2. When f at x is equal to 0, that means when y is equal to 0, what is x going to equal? So again, we're going to go to y equals 0 and draw a horizontal line with our straight edge. And it intersects the graph at x equals negative 1. F at x is equal to negative 2. So where y is equal to negative 2, again, let's go to our graph. And there is y equals negative 2. And if you look at your graph, it's an interval that intersects y equals 2. This interval there is where y is equal to 2. So when x is less than or equal to negative 2 and greater than or equal to negative 4, you write that down a little better at the bottom so it's a little bit clearer to see. So when x is less than or equal to negative 2 and greater than or equal to negative 4, y is equal to negative 2. Okay, if g at x is equal to x squared plus 6x plus 9, that quantity over x squared minus 9, find the value of g at negative 2. So, let's write it out, and then we're going to use store to help us out. So we can do negative 2 squared plus 6 times negative 2 plus 9 all over negative 2 squared minus 9. So if we evaluate our numerator first, using our calculator, negative 2 squared plus 6 times negative 2 plus 9, that gives us 1. And then if we do negative 2 squared minus 9, that gives us a negative 5, which is negative 1/5. But you could have also used store. You do negative 2 store x, and now to enter our function, actually a rational function because it is a fraction, you're going to press the following keys. Let's clear our screen at negative 2 store x. We'll do alpha y equals, let me write that down for you, alpha, then our y equals, and you'll see a screen shows up and you have a 1n/d. That means numerator denominator, and you're going to pick choice 1, and you'll see a fraction key will show up. In your numerator, you're going to enter x squared plus 6x plus 9 and you're going to arrow down and enter x squared minus 9. And then you're going to, alright, so, and you'll see you figure it out, you'll get negative 1/5. So using store was significantly easier, and it's a perfectly acceptable way to do this. Now we're going to rewrite this expression for f of 4a. We have 4a, okay, we do not have a numeric value. We have an algebraic expression there, 4a. So wherever there's an x, we're going to plug in 4a. So let's rewrite this as 4a minus 4 over 4a plus 4. Let's remember how to factor from Algebra 1. Our greatest common factor is a 4, so it's a minus 1. 4 times a plus 1. 4 divided by 4 is 1. So our answer is going to be a minus 1 over a plus 1. This concludes our second packet in this unit, and the answers to the homework will be available after they are due at the end of the week.